Hello and welcome to another Blender tutorial. Today I'm going to be talking about individual panels on aircraft. So this is a Betty World War II Japanese bomber I'm working on, and you can see that all my panels are individually made. I have a couple reasons for doing this. One of them is I don't have to worry about the continuity of edge loops going across the whole model. Now, if you made this wing out of one big piece, you'd have edge loops going all the way down, all the way this way, and some of them would need to be combined or split depending on the detail. By doing it this way, all the edge loops inside this panel are pretty much defined within the panel. All of your problems end at the border of the panel, and you don't have to worry about continuity from one panel to the next. Right? This one has more rows than this one does, and that's because it needed more. This one needs less. So it lets you put just as many polygons on each panel as needed without having to worry about carrying that detail throughout the model. It makes it easier, I think. Another thing it makes it easier to do is it has to do with UVs. Each one of these panels is almost UV unwrapped, right? You can UV unwrap that and it's not going to distort. You can imagine that most of these are going to UV unwrap quite well without any kind of effort. In fact, you wouldn't even need to cut many of these. You wouldn't need to put seams on many of these. Well, some of them obviously you do. Like this leading edge is going to need a seam so that the two halves get unwrapped. But for the most part, UV unwrapping is quite simple. You pretty much select everything, hit U, and kind of clean up the few things that didn't work. Another thing that doing the individual panels does is it makes it possible to create bigger textures more easily. Now that Blender does UDIMs, and we can spread our UV mapping out across multiple UV spaces. What that does is it lets us create higher resolution textures. Higher resolution bump maps, better color, more detail. And one of the reasons we can do that with the individual panels is because each of these panels is small compared to the overall scale of the project. It means they can be scaled up quite a bit inside here. So each of these panels is scaled up like 6 times the size that it normally would have been if I had just kept myself to a UDIM range of this first block here. And take a look. Like I said, this is a work in progress, but so here's a test render I'm doing. You can see our panel lines are crisp, right? You wouldn't get this if you used a bump map to define your panel lines. You could never get this close. And maybe in the project you're doing you don't need to get that close, but I like close-ups. So by defining the individual panels, I get nice tight edges. They're straight, and I almost have infinite resolution. As far as I move the camera, and that line is going to be tight. And you can also see that because my bump map is fairly high resolution, I get nice round rivets, and they're not pixelated or anything like that. So those are the advantages, I think. There are probably disadvantages, but I think the advantages outweigh the disadvantages. So what's the process for doing this? Let's see. Part of it is based on what I call a base mesh. And the base mesh is a group of very simple objects that define the volume of whatever it is you're modeling. And when I say simple, I mean use as few polygons as you can. Make sure the topology is really good and smooth. Avoid pinch points, have nice flowing lines, and don't put any more edge loops in than you absolutely need to, because there's going to be a subdivision surface on all these. And it's going to be bumped up a fair amount. If you've got wrinkles or pinches, it's just going to make things worse. So each one of these components is about as simple as I could make it to define the shape of my object. If we go into side view, you can see that my fuselage object fits the fuselage pretty well. My vertical stabilizer fits that. From the top view, I've got a nice match. Right, so using as few parts as possible, or as few faces as possible, create that volume, and then this volume is going to be used by the individual panels combined with a shrink wrap modifier to have those panels snuggle down against the base mesh. And that's why you need this extra sampling over here. This extra sampling gives more data to the shrink wrap, which makes everything much smoother. The other component to this is we need to define something that's going to give us this data, right? Because we want the panels not just to conform to the edge of the model. We want the panels to conform to each other, right? They're going to meet at very specific spots. They're going to follow curves very closely. These are all machined parts. The way I do that is by defining a bunch of planes. And if we look from the side of the fuselage, you can see the panel lines in the aircraft are very long and flowing, right? They go all the way down. They're almost like planks on a ship. And then they're periodically broken up with some vertical pieces. From the front, those long flowing lines are actually straight, right? So if I turn back on my fuselage edge shrink and select a couple of these, you can see that all I've done is I've taken those planes and I've run them through, the geometric center of this elliptical aircraft, and they line up on those lines. And then in 3D space, that's what defines that nice long sweeping curve. And then similarly for the vertical cuts on the sides, I simply created these, and they line up with the cuts, the vertical cuts. And what we'll do later on is we'll take our base meshes, copy some of the faces off of this, and then use these edge pieces to mathematically force the panels to fit tightly together. So I don't know exactly who my audience is, so I'm going to quickly jump over to some shrink wrap examples just in case people aren't familiar with it. So here I have two samples here. This first one is an example of a face smushing down onto some other complex shape. This is simply a face with a bunch of subdivisions, and this is another distorted set of polygons. What I want is this to snuggle down against that tightly. And we can do that by creating, let's put a subdivision on it first so that it's a little smoother. And then we'll put a subdivision on this one as well. And we'll crank this up to like 3. And then on this one, we will add a shrink wrap modifier. It's here under deform. And then you need to give it a target. This is going to look horrible because sometimes nearer surface point works, but other times projection works better. I'm going to choose the Z and both negative and positive axis. But if I hide that, that's pretty good, right? It shrunk down there nicely. We got a unforgiving mirror finish on it, right? That very quickly did exactly what we needed it to do. Shrunk it down so it perfectly matches that. Now you can also you don't have to do faces, you can also do edges. So let's say we needed this, let's say you're doing like a bulkhead inside the aircraft and you wanted it to fit to the curvature of the fuselage. Well, you could do that here as well. Pretty much the same process. So here we have our target, and we're going to put a subdivision on it just to make it a little smoother. And this is going to be the piece we're going to shrink wrap. Now in this case, we don't want the whole object to shrink wrap. We only want this bottom row of vertices. And we can control that by creating a vertex group and assigning that group of vertices to that group. And now if you go to, put a subdivision on it. And now if we go and create a shrink wrap, we're going to pick the target, but we're going to pick that group first, and then we're going to pick the target. And we're going to change this one also to project and negative Z. Right? Look at that. How awesome is that? All right, so if that was a bulkhead, you wouldn't have had to, you just saved yourself all that time of pushing points down and trying to get them just to match exactly. It's important to remember that until you actually apply this shrink wrap, it didn't actually move the geometry. And we'll talk about that later. So sometimes, when you get stuff set, it's not a bad idea to apply it, and then now the piece actually is that shape. All right, so that's it for those examples. Let's talk about how we would actually do do a part. Let's do a nacelle. Well, we'll make a couple of panels for a nacelle and see how it works. So if we turn on the shrink for the nacelle, this is our starting point. We're going to take this and we're actually going to duplicate it, and I'm going to move it to a collection that I set up in advance. And we don't need that right now. And we'll go down to our sample thing here. And all right, so this is the copy we created, and we're going to use this as a feeder for all the panels that we want to make. But before we do that, we're going to do some housekeeping on this stuff that'll save us a lot of time later on. First thing is I want to rename this. Oops, I don't want to call it that. I'll call it cell panel. The reason I do that is we're going to copy and duplicate faces off of this, and every time we create a new object based off of this, Blender's going to rename it, and it's going to just assign a 1, a 2, a 3. So Blender's going to take care of all of our naming, which is nice. The next thing I want to do is I want to go to vertex groups, and we're going to create those vertex groups. We're going to create 6 of them, 3, 4, 5, 6, and these are going to be used to define the edges of each panel. So we're going to have front, back, top, bottom, inboard, and outboard. And these will be used to define the relative position of the edge guides that we create. Every panel we create is going to have some combination of these. And let's go over to the modifier stack. We're going to keep the subdivision surface, but we're going to turn it down a bit. And we're going to create a bunch of shrink wrap modifiers. Now I'm going to hit Shift D here, 2, 3, 4, 5, 6. And this first one, the target's going to be the nacelle shrink. Right, so this is the base mesh that we copied this from, and we're going to use that to keep this thing nice and tight on that volume, and I'll rename this as base. These remaining shrink wrap modifiers are all associated with the vertex groups that we just created. And so I'm just linking those here, the vertex group, the top one, and then I'm just going to quickly rename these so that they're easier to find later. And this may seem a little tedious now, but you would otherwise have to do this for every single part, every single panel that you cut out. So it's best just to do it once and be done. All right, and we don't need any of these on right now, and we'll never need to render them, so I'll leave all that off. And I also create a Solidify because we want our panels to have a little bit of depth, maybe 3. And you can see that in the test render I did here, that sometimes you're going to need that. So around this exhaust port or around the cowl flaps here, there is some gaps, and you don't want a 2-dimensional piece there. So I generally do only rim, just so I don't have the extra geometry. And we don't need to see that right now either. And I do want to keep the mirror, but it's just going to get in the way for now. So this is the piece we're going to use to create all of the subsequent panels for our nacelle. So if we open up the shrinks for this, let's try to make this piece here. So what I want to do is I want to go into edit mode on my nacelle. This is the copy. All right, I just want to be clear. This is the copy we made, and I want to go into face mode, and I'm just going to select a bunch of faces that roughly consume that space. It doesn't matter that it goes too far, and it wouldn't matter if it came up shy on any edges. That's not important. What we're really doing is just creating a starting point. So I'm going to hit Shift D delta and P, and I'm going to separate by selection. So now we just created a new object. Right? And that new object, you notice, has all the modifiers we put on it. It has the vertex groups, and it's pretty much ready to go. So now what we want to do is we're just going to make our work environment a little bit less cluttered. So I'm just individually selecting the borders and the piece, and then I'm going to hit Control I as in India, and then H hotel, and I'm going to hide everything we don't need to see. All right, so let's start trimming this down. For the back, I'm just going to Control R, and I'm going to create a new edge loop there, and I'm going to hit Control X on those because they're not needed. And then we don't need these. You know what? I think I took the wrong. Yeah, that's the one I wanted. Sorry about that. Hide that. Try that one, this one, and that one. Better. Okay. So you can see these are a little proud. That's fine. GG. I don't know if you know that trick. Hitting GG lets you move things along the normals. Try to see if I've got extra face. What that face is doing there. Don't want it. All right. All right, so there's obviously not enough definition in this piece to make this. So I'm going to hit Control R a couple times. And if we turn the shrink wrap back on, you can see that it's already doing its work for us, right? It's already reshaping this to match the curve that we want. So here I'm going to hit GG again, it's the Gulf, and that lets us move along the normals. And if I hit the letter C, as in Charlie, it lets me move along the normals in the other direction. And all I'm doing here is getting my parts close. Okay, and I'm going to add a couple more edge loops in here, just so we have, because they're going around a corner. If you select a row and you right click on it and go to Loop Tools, there's a function called Space, which is awesome. I use it so much I've created a shortcut for it, Control Q. And what that does, it's going to space out evenly all the points along the line. So I can make short work of this by double-clicking, hitting Control Q, and gives me a nice even grid here. All right, and the more even your grids are, the better. And we'll clean this up later as we move stuff around, but that gives a good starting point here. Now we want to assign the vertexes to the various vertex groups. So we'll call this one top. Double clicked on that. I call it top. I'm going to click on the top and I'm going to assign it. I'm going to do the same thing here. Call this one back. Assign it. Call this one bottom and assign it. All right, now if we go to the modifier stack, we can turn on back. And we want to tell the shrink wrap that this is the back. And you can see how that worked, right? If I click on, I can toggle this. You can see it's snapping it right to that line. And the great thing here is that the panel that's adjacent to this in the back will snap its front face to the same plane. And that's how we maintain perfectly parallel edges between pieces. So let's do the same thing with the bottom. I want to turn on the bottom, and that's this target. And that wasn't as obvious, but if I took a couple of these points and dragged them up, you can see that it's snapping it down nicely. And then we'll do, what I said, the back and top. We'll do top next. And that'll be this piece. And turn that on. And that one's pretty close too, so we're not seeing a lot of movement. But if I toggle it now, all right, we can see all that stuff moving around. So that's those shrink wraps, the base, the back, the bottom, and the top in this case, define all the edges and volume of this panel. Now it's sometimes useful and sometimes necessary, often necessary, to duplicate your shrink wraps and then apply them. And the reason you want to do that is if I turn like this one off, these points really aren't up against this edge, right? I move them out of the way, and this is just kind of an illusion that that's where they are. We want to eventually re-space all these pieces based on the real line of points here. And the only way to do that is to duplicate and apply them. So if I duplicate and then apply the second one, and then if I do the same thing with the bottom, duplicate it and apply it in the back, and I duplicate it and I apply it, now I can turn these off because we've used them to establish our edge. And then the last thing I want to do is, now that we've defined the perimeter, now I can go back and do the Control Q thing again, the space, and I can get an accurate distribution or redistribution of my points. These aren't moving too much. And that's because we were pretty close to where we needed to be. One more thing before we get out of edit mode is we want to select the edges, and if I had N as in November, go up to set the mean crease to 1, and that'll give us nice sharp edges when we do our subdivision. So let me hide these things. All right, and that's our part. Now if we go into matcap, you can see that we've got a nice smooth piece, absolutely perfectly straight edges, and these edges are going to butt up against other edges. Before I started this tutorial, I created a couple sample pieces. So you can see that this new piece fits absolutely perfectly with that other piece. Oh, and it also sometimes is helpful to hit auto smooth as well. That'll keep that edge sharp. All right, so that's the process. Sometimes you can only take the process so far. So let me get out of this, and we'll close the shrinks, close the sample, don't need that, and we'll go back to this. No, I want to go back to the model actually. That does work. So for a lot of these pieces, that process works. Sometimes it's not going. Sometimes you're going to have to. You can use the shrink wraps to get so far, but then you're going to have to apply them and then finish modifying them. That's particularly true with control surfaces, because these, they're not rigged yet, but they're going to have to move at some point. And when they move, if they were still shrunk wrap to the underlying surface, then they would deform. So for something like rudders and elevators and stuff like that, use the shrink wrap as long as you can to get the basic shape. But then when you go to have to actually add like maybe the leading edge or some other details, you're going to have to apply that shrink wrap, and you're just going to end up with a subdivision surface on it. And that's, like I said, that's kind of few and far between. It's mostly the control surfaces, the ailerons, the flaps, bay doors, that kind of stuff are going to have to be separated from the shrink wrap process because they're movable. Okay, and there's only one more thing here I can think of to talk about, and that's the shader that I put on these. Because if we go back, we close the model, and we go back to the sample that we made, and we render it, you can see it's very, very sharp. This is unnaturalistically sharp. So what we want to do to fix that is we go to the shader, and this is just a principle with italic turned on and roughness turned all the way down. To make these panels pop out a little bit, add a bevel to it, and you're going to feed this into the normal. And by default, it doesn't look too good. But if we make this like 0.03, with some more render samples, this starts to look good. This is what I actually end up using. So there it is without it. It is razor sharp and very difficult to see. But throwing that on there gives it just enough of that glint on the edge to make the panels pop out. All right, well, I think that's about all I can think of for this particular topic. I appreciate you listening, and thanks for watching the whole video. All right, take care.